Alright, this is the Target 7B retake video. So you're gonna do a few problems, watch me do a couple problems, and then you're gonna do some on your own. And remember, you have to show them to your teacher, a math lab teacher, or a support teacher, to get your work approved, and then you can do the retake. Okay, so for problem number 1, it's asking us to classify this figure as specifically as possible and to justify your reasoning. So you have the quadrilateral family tree. You should be looking at that and seeing. So which of the quadrilaterals has 4 90-degree angles? These markings are 90-degree angles. And it has 4 90-degree angles, and the two things that have 4 90-degree angles are squares and rectangles, right? Rhombuses and kites have 90-degree angles at their diagonal, so inside there's 4 90-degree angles for a rhombus and a kite, but not the outer corners like these. Okay, so this looks like it's either a rectangle or a square. Now, it looks like JK and JM are not equal sides, so it doesn't look like it's a square to me. It looks like it's a rectangle. So I'm going to say it's a rectangle. And the reason I'm going to say it's a rectangle is it has 4 90-degree angles. Okay, but all 4 sides are not equal. If all 4 sides were equal, then it would be a square. But all 4 sides are not equal, so it's a rectangle. So the reason is it has 4 90-degree angles, but all 4 sides aren't equal, so it's a rectangle. Now it says as specifically as possible. So this most specific is rectangle. Now a rectangle is also a parallelogram, so this is a parallelogram. And it's also a quadrilateral because it has 4 sides. Okay? But we wanted the most specific case. So the most specific case is rectangle. Okay, number 2. Josh argues that the figure below is a trapezoid. If you agree, justify why it is a trapezoid. And if you disagree, reclassify it and justify your reasoning. Okay, so a trapezoid has 1 pair of parallel sides. So looking right at this, these do look like there's 1 pair of parallel sides, right? So that's looking good for a parallelogram, for a trapezoid. However, it doesn't really look like a trapezoid to me. So it looks more like a rectangle. And once again, a rectangle has 4 90-degree angles. So this has 4 90-degree angles. So remember, a trapezoid can only have 1 pair of parallel sides. Okay? But since these two angles are both 90, and 90 plus 90 is 180, that says that these two angles here are supplementary. And we have a theorem that says if same side interior angles, and if I'm looking at these 2 lines here, and this transversal, if I have same side interior angles equal, that makes the lines parallel. So it turns out that these 2 sides are parallel too. So this is not a trapezoid. This has 2 pairs of parallel sides. It's actually a rectangle. So I'm going to say this is a rectangle. Because both pairs of opposite sides are parallel. And it has 4 90-degree angles. A trapezoid can only have 1 pair of parallel sides. Okay, so my advice for you on these problems is look at them. On first glance, it showed that there was one pair of parallel sides, so it looked on first glance that maybe it was a trapezoid, but it didn't really look like a trapezoid. Okay, so then I looked at it and I could show that the other sides were parallel, so that's enough for me to say, yeah, this is a parallelogram, and because it's got 490-degree angles, it's actually a rectangle instead of a trapezoid. Okay? Okay, and for problem number 3, we have to prove that ABCD is a square. So to show something is a square, we need 4 equal sides and 4 right angles. So I'm going to find the distance of AB, BC, CD, and AD, and see if the sides are equal. Now it says prove that it is. Now it's not saying determine what it is. If you're determining what it is, you're not sure what it is going in. This is saying prove. So this is a square. We just have to show it. Okay? So again, the way I do distance, instead of using the distance formula, which will work, so if you prefer the distance formula, you're certainly more than welcome to use the distance formula, but I prefer to use the Pythagorean theorem. So to get from A to B, I'm going to go up and over. It looks like I'm going to go up 1 and over 1, 2, 3, 4. Okay, so the length of AB is 1 squared plus 4 squared, because this is a right triangle, and that equals AB squared. And if I square these, I get 1 plus 16, which is 17. But because I want just AB, so I get AB squared is 17, so AB is equal to root 17. So I know that the slope, or that the length of AB is root 17, so I'm going to mark that in here. That's root 17. I'm going to do the same thing for BC. And I'm going to look at this. I'm going to say that's 1, and this is 1, 2, 3, 4. Okay, so again, BC squared is going to be 1 squared plus 4 squared. Well, wait a minute. If I'm squaring 1 squared plus 4 squared, I have no other choice except to get root 17. So I know root 17 is again BC. And then I can notice the same thing for CD. That's sloppy. Let me try to draw that again. Okay. Over and up. So 1 and 1, 2, 3, 4. So again, this is going to be root 17. The DC is going to be root 17. And AD looks like it's also going to be root 17. So, yep, 4 squared and 1 squared is going to give me root 17. So AD is also root 17. So now I know that there's 4 equal sides. Okay, now I have to show 4 right angles. So to show right angles, I'm going to show that the sides are perpendicular. And remember, sides are perpendicular if they have sides are perpendicular if their slopes are negative reciprocals of one another. So I'm going to look at the slope of AB. And I should write M for slope. This time M is standing for slope instead of measure, so the slope of side AB is, remember, rise over run. So to get from A to B, I rose 1 and I ran 4. So it's 1 over 4. Now the line that looks parallel to it is DC, so let's look at the slope of DC. And DC, rise over run. It looks like I ran 4 and rose 1, so it's still 1 over 4. Okay, and then I also have to find the slope of BC. So the slope of BC is rise over run. But look, I want to go from left to right. I have to go from left to right. So I run 1, but I don't go up, I actually go down 4. So I actually go down 4 for rise, and I run 1. And then the same thing for the slope of AD. From left to right, I go over 1, but I go down 4. So this is negative 4 over 1. Now, are negative 4 over 1 and 1 over 4 opposite or negative reciprocals? And they are, right? If I flip 1/4 over, I get positive 4, but then I'm going to change the sign and I get negative 4. So it turns out that this also has 4 right angles. So we showed that it had 4 equal sides. They're all equal to root 17. And we showed that the lines were perpendicular, which means it has 4 90-degree angles. So this is a square. Alright, so the following 3 problems you have to try on your own. And then again, have them checked with a teacher before you can do the retake. So you want to pause and solve them and then come back and finish. So here's, sorry, I skipped too fast. The first one, you have to classify this, remember, as specifically as possible. So we're looking for the most specific term. And number 2, Josh says that this is a rhombus. You have to decide if you agree with him or not. And number 3, you have to prove this is a kite. Okay, good luck.